So question 3 is, the use of epoxides as alkylating agents for diethylmalonate provides a useful route to gamma-lactones. Write a sequence beginning with styrene oxide that will yield this molecule. So the best way to really break this down is to first ask yourself, what are the two reactants? So you know that one of the reactants is diethylmalonate. And you know that one of the reactants is styrene oxide. And again, I got questions in office hours this week about whether you would be expected to know this. No, if you type in styrene oxide in Google, you'll see that that is what styrene oxide looks like. So if you generate a nucleophile here and you have this epoxide, as we talked in class, you have the ability for this nucleophile to attack one of the two positions on this epoxide. For this example, we're going to talk about it attacking right there. Okay. So this is the product that you get out of this. So diethylmalonate followed by hydrolysis of these esters will give you this. Right, and so then this actually becomes, I think, pretty straightforward once you get to this. Because what you can do is that if again, you use what the question gives you, diethylmalonate reacting with this epoxide, you know that it's going to react one of these two places. You know, if you happen 50-50 shot, you get this molecule out. When you acidify this, this now becomes, especially as it's drawn here, becomes a perfect substrate for Fischer esterification. And then we get to this molecule. Simple decarboxylation at this point will give you this. The other possible product of this reaction comes from the nucleophile reacting at this position. And I'll leave it to you to draw the intermediate which leads to this lactone. But I think what's important to look at here is the question of which of these two positions is more favored for this reaction. And this is actually a much more complicated question than you may realize. Is that, so when we talked about this in class, we talked about the SN2 versus the SN1 positions for nucleophiles attacking epoxides. On the surface, this may seem like the SN2 position, and this is an SN2 type reaction. When I say SN2 type reaction, I'm talking about when we dealt with substitution reactions, and we dealt with strong nucleophiles react in SN2 type reactions, weak nucleophiles react in SN1 type reactions. But this is actually a very, very special case. Alright, so this is what our epoxide is going to look like. The nucleophile can either attack here or here. This is what's referred to as the benzylic position. And remember, there was something very special about SN2 reactions, either benzylic or allylic positions. And that is that as the nucleophile approaches, it's stabilized by the pi electron density, which aligns itself with the approaching nucleophile coming to that position. So in practice, both of these positions will react. This is the more prototypical SN2 position. This is also a very valid SN2 position because of the assistance you get from the pi ring here. So you can get either of these two products, right? And it's all dependent on how this diethyl malonate reacts with this epoxide. But I think the most important thing to look at here is that if you look at this question, this is really a pretty simple question, is that you start with diethyl malonate and you treat it with a base to get this nucleophile, and it reacts with an electrophile, right?